Welcome. My name is Mr. Sunarine, and today we'll be looking at what are some ways that we can demonstrate that fractions are equivalent. Before we get into the lesson, I'm going to review some math vocabulary that's going to be very helpful in understanding this lesson. Here, I'm going to be discussing what is a numerator and what is a denominator. The numerator is when you think about how many equal parts do you have. The denominator is how many equal parts is the whole divided into. So in this diagram, we see a picture of pizza. We see that there are 4 pieces. 1, 2, 3, 4. How many equal parts is the whole divided into? So there are 4 pieces that it is divided into. The numerator, however, is how many equal parts do you have? So I see that 1 piece is missing, and therefore I have 1, 2, 3. I have 3 pieces left. So therefore my fraction would be 3 out of 4, or 3/4 would be its name. Now we're going to get into the lesson. Here are some prompts that I want you to look at, answer, and try on your own. What is similar about these two models? What is different? Fill in the fraction for each in the box. So based on what was provided in the last slide, I want you to try to develop what the fraction will look like for this diagram. Here's one example, and here's the second example. When you're finished, I want you to write down some similarities and differences that you notice. And you can pause the video, record your responses, and on the next slide, we're going to compare our answers. So for here, in the first diagram, our fraction is 4/6. We first count how many equal pieces do we have. We have 1, 2, 3, 4, 5, 6. That number goes on the denominator, which is on the bottom. The top number is how many pieces you're shaded. So here we have 1, 2, 3, 4. There's 4 pieces that are shaded. Therefore, our fraction is 4/6. Next, we're going to look at our next fraction. Here in this diagram, we have 1, 2, 3. 3 is our denominator, and 2 pieces are shaded. So we have 1, 2. So our fraction is 2/3. Now we're going to look at some similarities and differences. In our similarities, the portion of the models are shaded in. Here, we see that based on the two fractions, the same portion is shaded in. Another similarity is the portions of the models are not shaded in. So the same portions that are not shaded, these are not shaded in. They're the same. Now let's look at some differences. One fraction is broken up into 3 equal pieces, and the other is 6 equal pieces. In the first one, we see that it's broken up into 6 equal pieces. 1, 2, 3, 4, 5, 6. And then on the bottom, it's broken up into 3 equal pieces. 1, 2, 3. Another difference is there are different equal pieces shaded in. 4 equal pieces and 2 equal pieces. So looking at the shaded portions, we see 1, 2, 3, 4 is shaded in, and the bottom one is 1, 2. 2 is shaded in. Now we're ready to move on to the next slide. In here, I want you to, when the whole is the same, why does it take 6 tiles of 1/8 equal 3 tiles of 1/4? So here are some tiles that's available for you, and I want you to explore this on your own. And on the next slide, we're going to go over how to work through this problem and make sense of it. So try this on your own, and we're going to move on shortly. To help you with this problem, we're going to look at when the whole is the same, why does it take 6 tiles of 1/8 to equal 3 tiles of 1/4? So What I provided here is the 1/8 are provided here. We see that it's green, so we could even move it here, and we notice it follows the 1/8. It covers it up. So I'm going to move it back. 1/4 is the blue tile, and we can move it up here to show that it's the same over here. Now, if we look at our diagram, we see that it takes 2 1/8 to equal 1 1/4. So 2 of these green tiles to equal one of the blue 1/4 tiles. And if we're able to write our fractions, which is provided here, let's look at how we can write those fractions. So to develop 6/8, we look at 6/8 and we see that the green is associated with 1/8. So let's look at it. Let's start with our denominator. 1, 2, 3, 4, 5, 6, 7, 8. 8 is our denominator. Our numerator is 6. So let's see how many pieces are shaded in. 1, 2, 3, 4, 5, 6. So there are 6. There's 8. So we would name this 6/8. Let's do the same thing with our 3/4. So there we count how many spaces, how many pieces of 1/4 do we have? 1, 2, 3, 4. So 4 is our denominator, and 3 is how many pieces we have. So 1, 2, 3. 3 over 4 is 3/4. Now we're going to look at some example that will discuss this even further. And it looks like 2 of these 1/8 will equal 1/4. So here was the same prompt from the last slide. I'm going to read another explanation. 8s are smaller than 4s. So you need more 8s to equal the 4s. And 8s are half of 4s. So if you have 3/4, you double 3 to get 6/8. I want you to write down what do you notice about this word? What questions do you have? I'm going to provide some notes for you for the next slide that will talk about the 3/4 and the 6/8. And there's a special name that we call this example. Here are some noticings. 3/4 and 6/8 are what we call equivalent fractions. They both represent fractions with different numerators and denominators that represent the same value or proportion of the whole. So if we see these two examples, even though they have different numerators and different denominators, they still represent the same proportion in different ways. Here we see 3/4. 3 pieces are shaded in out of 4 pieces, and here 6 pieces are shaded in out of 8 total pieces. This would be an example of equivalent fractions. Now we're ready to move on to summarize even further our learning. To prepare for the summary, record your response to the focus question. What are some ways that we can demonstrate that fractions are equivalent? And feel free to pause the video, record your responses, and resume. I'm going to provide some summary notes for you to add for your notes. So we're ready to move on. In order to answer our prompt, what are some ways that we can demonstrate that fractions are equivalent? We can use visual diagrams and written fractions. Here are some examples of visual diagrams, and here are some examples of the written fraction. And here are some notes for yourself. I noticed that since 3/4 and 6/8 are equivalent fractions, if I have a fraction, I can create an equivalent one by multiplying the same number on the top, the numerator, and bottom, denominator, to create a new equivalent fraction. So if we see in this example, we multiply 2 on the top and bottom from 3/4 to get 6/8. And in this example, from 3/4, we multiply 3 and 3, and we get 9/12, which is 9/12. this was helpful. Have a great day.